Hi everyone, my name is Manon and I am a software engineer. Next Monday I am going to be facilitating a code retreat and I haven't done one in a few years because of COVID. So I thought as a good refresher I should probably try and have a go at the exercise myself. Before I get into that though, what is a code retreat? A code retreat is simply like a day where a group of software engineers get together to perfect their craft. The best example that I always use when explaining a code retreat is that when you're learning a musical instrument, you don't just kind of try and rush through a new song you're trying to learn to play. You go really slowly, but you make sure that you get each note perfectly correct. When we, are doing software engineering in our day-to-day job life, it's usually the complete opposite of that, which is the mad rush to get as much stuff out the door as you humanly possibly can. So it's not a great opportunity to learn how to, develop your skills. It also is a good opportunity to pair with new developers. I've never really come out of a pairing session without learning some new trick. It can be something as simple as a keyboard shortcut, or it could be a new pattern, or a new way about thinking about writing code. So it's kind of a combination of those things. Today I don't have anyone to pair with. I'm all by myself, so I'm going to have to pair with myself, so that'll be an interesting challenge. And typically in a code retreat, you do a 45-minute session, which is what I'm going to do today, but you do that 5 times. Hopefully I can get enough done in one session that I don't need to do anymore, but we'll see how we go. And the actual session itself is implementing Conway's Game of Life. So there's some explanation around what that is, but I'll get into that just before I start coding. And yeah, that's pretty much it. I'm not an expert by any means. I'm still learning and developing in my craft. I haven't done one of these for 6 years, and if you know me, I don't have a good memory. I don't even know what I had for lunch yesterday. So I feel like I'm kind of going into this blind, which is what I'm trying to do. So we'll see how we go. So to get started, I'm going to check out a starter project. So this just basically has Kotlin and Java in here, and just like a simple unit test, like I can show you, it's like 1 + 1 = 2 kind of thing. But what this means is just we don't waste a lot of the time in the 45-minute session, importing packages and doing all that boring low value stuff, and instead we're just going to get straight into the coding. So the game of life is just kind of 4 simple rules that affect like a binary grid. So sort of like this example up here. And these rules are really simple, but what happens is after each iteration, the board kind of moves like it's alive, and that's why it's called like the game of life. It's kind of like a simulation of like cells you can think of, or population of animals. So the rules are, any live cell, which is shown as like a black cell up here, if it has fewer than 2 neighbors, it will die because it's underpopulated. It doesn't have anyone to meet. It's very lonely, like me in my pairing situation today. So, if it has less than 2 live neighbors, it will die, which means in the next iteration it will go from live to dead. If it has more than 3, it will also die, but not from underpopulation, but from overpopulation. And if it has exactly 2 or 3, it will stay alive. So that's like the optimal number of adjacent cells. And in any dead cell, that has exactly 3 live neighbors will come to life. I always call that one the zombie scenario, but I guess it's kind of like, you could think of it more as like the live cells have kind of expanded into sort of vacant territory. So yeah, and then if you randomly populate the board, then you can see all these kind of cool patterns emerge. So yeah, hopefully it'll make more sense as we get into it. So what I'm going to do is just going to go ahead and clone this project, and then we can start a 45-minute session. Alright, I'm just going to clone that now. And once it's cloned, I will create a new branch for the project. 2022 session 1. And then I'm going to use IntelliJ as my ID of choice, but obviously you can use whatever you feel most comfortable with. Okay, so now I have the project open in IntelliJ. So in the README here, we've got the same rules defined in here that we can refer to if we need to. I'm also going to just delete these Java folders, because I'm going to do this exclusively in Kotlin, which will be interesting. Last time when I did it 6 years ago, it was in Java, so never done it in Kotlin before, so this will be an interesting challenge. I'm just going to run the verifies to make sure the build's working. Fingers crossed. Running tests, yep. Okay, so that's good. It's still got the old Java libraries here. Let me clean out the target folder. It also generates the code coverage, which can be handy to make sure you haven't missed anything. Alrighty, so tests run. So if you look here, there's just like a simple class that does literally nothing, and a test that does pretty much next to nothing. Alright, well, let me start the 45-minute timer, see how far into it we get. And yeah, alright, let's get started. I'm a little nervous. Alright, the timer started. So let's try and introduce some sort of business logic here for the different conditions. So if we go to this test, because we're doing TDD, we can do something like cell logic service. So the test is failing. Let's create a class, cell logic service, and let's rename this test to be cell logic service test. Let me increase the font so that hopefully it should be easier to see. And then we can get rid of this Kotlin sample. And now if we run this, everything should still be green. I can also run it in IntelliJ. Cool. So let's do like calculate cell state as a method. Cool. Again, run the test. Should be green. Alright, now we're getting into some actual logic. So we want to pass in the current state. So maybe we'll create a cell and then cell state dot alive or something. Probably did too many things. Let's just do one at a time, man. Normally, if I had a pair here, they would be doing the, either the test, and then I would write, the code, and then we flip-flop. Alright, so I'm using a data cell, which is a Kotlin struct type thing. I think in Java 11 or something it's called a record. So it needs at least one attribute. So I'm just going to do val state. I'm not doing TDD. Alright, let's do some TDD. So let's go back to the test. And let's put in cell state.alive. So basically what I'm trying to do here is I'm trying to, if we do something like target cell equals cell state alive, I'm just basically trying to say like the current state of the cell. So I'm going to create an enum called cell state, and it's going to have alive or dead. And then I'm going to add a parameter to cell for called state, and then in here I'm going to create a method called target cell. So basically this is saying given a cell, target cell, what is its new state going to be? And if we run this, hopefully it should pass because it's not really doing anything. And then we're going to pass in neighbor cells and this is a list of cell. So given a cell and a list of neighbors, we're going to hopefully tell us what the new cell state should be. Okay, and let's say should be cell state dot live. Okay, now the test should fail. So we're saying given an alive cell with no neighbors, the cell state should be alive. And it's saying, this method is returning nothing, a unit, and you're expecting it to turn alive. So doing the minimum to get this working, I can just do return cell state dot alive, and then we run the test. Sorry, it's probably going a bit fast, but it's hard to do it when you're doing both the TDD and the actual live code and also trying to narrate your experience. It's a new thing to me, so apologies if it's not very clear. So yeah, at the moment we're saying given an alive cell and a list of neighbor cells, the next state should be alive. So if we go to the README, it says any live cell with fewer than 2 neighbors dies. So really our test is wrong because it should be dead. So again, the test will fail. And to make it pass, we can just do dead. So let's give it a good name. So this is like a live cell with no neighbors should die. Very macabre things. So we can leave that test now. And then an alive cell, what does it say? With more than 3, so 4 or more neighbors should die. So a live cell with 4 neighbors should die. So let's create 4 alive. So this is an alive cell and it has 4 alive neighbor cells. And luckily with our awesome code logic, it's also passing, and that's just because we've hard-coded dead as the return state. So let's try now the next rule. Any live cell with 2 or 3 neighbors should stay alive in the next generation. So let's do live cell with 2 neighbors should live. So we can do that. So this should be alive. Okay, so it's failing now. And this is kind of where you get to the point of doing ping pong, where just hard coding a value isn't going to work anymore, because if we change this to alive, it's going to pass this test, but then these 2 tests will fail. And to just demonstrate that, we can just do this, and we should get 1 test that passes and 2 tests that fail. So which makes sense. So now we actually have to start doing some work, unfortunately. I guess we've been 9 minutes into it, I guess, so far. So what do we want to do? We want to know how many val number of alive neighbors, and here we can do neighbor cells dot filter it dot state equals cell state alive dot size. So basically we're just going to filter all the neighbors and get any that are alive and get the size. And then to get these tests passing, we can just say if number of alive neighbors equals 2, return cell state alive. So let's see if that works. And you can see here we're not currently interested about what the current cell is. We're just kind of only doing it on the kind of assuming that the target cell is always alive. So let's go, just now we've got red, green refactor, so the test is green. So let's just tidy this up a little bit. We can just make it a little bit nicer. Why is it not popping up? It's making me do it myself. My favorite joke is IntelliJ, more like DumbJ. So yeah, we should be able to run the test now, and it should still pass. It's just kind of cleaning up the code a little bit. Alrighty, so let's do another test. So a live cell with 3 neighbors should live. Let's give that a go. And if you're playing along at home, it's probably pretty obvious that this isn't going to work. So we're still implementing this cell logic here. So yeah, it's not working, no surprise. I think there's some Kotlin way of saying if a number's in a range, but I don't want to waste any time looking that up. Just mindful of, got a lot to get through in this 45-minute session. Okay, so all the tests are passing. Alright, so I think that's all the alive scenarios that I can think of at the moment. I think you can do nested and then inner class alive scenarios. This is just a way of breaking up your tests into smaller things. So now if we run this, it should give us like an extra breakdown. So now we can do dead scenarios, and then let's steal one of these tests. So now we're going to actually change the target cell to be dead, and the rule is saying if you have exactly 3 neighbors come to life. So what we can do here is, this is already 3, actually this is perfect for us. So we want to run. So that's already working, which is amazing, but I think it's more of a fluke. Just of the way that implementation, so, oh, that should say dead cell with 3 neighbors should live, dead cell with 2 neighbors should remain dead. So let's run that. Oh, that's also, yeah, no, see, bad written test there. Alrighty, so expected dead should be alive, and that makes sense because we're not kind of, you know, interested in this target cell. So I think what we want to do is maybe go something, I guess let's just go red green refactor. So if target cell dot state equals cell state dot dead, then we're going to do dead logic, and dead logic is basically if the number of neighbors is exactly 3. Otherwise, we're going to do alive logic, which is this. So let's run all the tests for both alive and dead states. Cool, everything's passing. So hopefully that logic should be done. So it's currently 30 minutes and 45 seconds, so it's taken us about 14 minutes to kind of get here. I'll quickly just add another test. Dead cell with 4 neighbors, and just go here. Just trying to cover some edge cases. You know, ideally I guess we could write a loop that iterates from, you know, 0 to 8 or 9 or whatever the maximum number of neighbors is. So I think that's probably good for our cell logic at the moment. So let's create another class called, I don't know, let's just call it a board. That's probably a better name for it. And let's get rid of this. So what we're basically going to try and do next is actually have a board or a map of cells. So we basically want to pass in a list of cells to kind of represent like a map. So what does that mean? So let's create a new cell board. And in the cell board, we're going to pass in a list of cells. So let's go cell, and then cell state alive. So you can kind of think of it as like a row and column kind of implementation. So it's gonna work. So it's a list of cells. Let's call this, I don't know, board. Really struggling. I think the time pressure is getting to me. So here we've got a cell board, list of cells. I can turn this into a variable called alive cell. So let's say we want to do 8 by like 6 or something of cells. So we can do, what's that? 6, 7, 8. So this can be a row, and then we want how many rows, like something like that. This is just assuming every cell is alive, which is not perfecto. So let's run this. We're not really testing anything though, are we? So yeah, so basically what have we got here? So what we want to do is kind of calculate next state. So board dot, so val next state should equal board dot next state, calculate next state. So we're basically asking the board to give us a new board, which will be the next state of the evolution. So create member function, and we're going to return a new cell board. And what we can do now is just return itself. And let's return this. So if we run this, it should still work. And so what am I trying to do? So we want to say next state dot board. Okay, let's make them dead cells. Maybe that makes more sense, easier to test, right? So we make this a dead cell and make them all dead. And the next state dot board dot for each. Oh, I just need to make this a val and make this a data class. So this just data classes again just like give you access to some things. Cool. So we're basically saying, hey, can you give us a next state for the board, next state board, dot for each, and then it dot for each. So let's call this row, and for each row, call this a cell dot state should be dead. So basically, given a completely dead board, when it calculates the next state, everything should still be dead. And that, is kind of the easy scenario, because dead cells can only come alive when they're next to 3 alive neighbors. So if we run this, that's exactly as we kind of expect. Everything's dead, because you need at least 3 cells on here to be alive that are next to a dead cell to kind of zombify and come back to life. So, obviously we're not implementing any of that logic yet, because we're just kind of returning itself. So what we could do, let's just create a print function, just because this is getting hard to kind of visualize. So if we go next state dot print, and we want this to be a string, we can kind of run this, and it's saying it wants a string, and we're giving it this. So if we go in here, so I've just copied the loop thing here, and in here, can I put string? I'm being too fancy. Let's not worry about that. So is there a string builder in Kotlin? Let's have a look. String builder. I mean, probably no point to do a string builder, but let's do it anyway. So here we want to do like if cell.state equal to cell state alive, then string builder dot append. Let's append an x. Else dot append a space, and then every row we want the thing to append a line break, something like this. I've just realized I'm not doing TDD, so I fail, I guess. So in here we run this. We should hopefully see interesting, it's showing us space. But I'm gonna be naughty and I'm not gonna do a test for this, but I'm just gonna go board.print. So what does this look like if I run this? I'm just trying to create some sort of visualization of what's happening. So yeah, it's kind of printed this, which is not very helpful because it doesn't really give you any context around what it kind of looks like. So maybe I'm gonna go, what does this look like? Oop. Helps if I stop escaping quotes. Alright, we've got 20 minutes on the clock. I feel like I wasted too much time on that. So we've got our little cells here. We don't really have a top part here. It's fine. It's kind of giving us some idea of like what's happening inside. So if we go back to our test, so we've got our rows, and these are dead rows. So a dead row is a row of just dead cells. So let's so for one of these rows, let's add some live cells. Actually, if we just create a whole row of alive cells. And so, and then we just pick one of these as alive. If we run this, you know, it's just gonna, because we're echoing back the, you know, the current board being passed in. It's failing our test. Like every single one of these rows, cells should die because they have. Oh, actually, no, they shouldn't die, should they? Let's just call it row with one alive cell. So this one should die because of what's the word? Underpopulation. And think of it like the last man on Earth or something. So there's just row with one alive cell. So here, you know, it's found one alive cell, and that one should have died off. with overpopulation. And if we go here, you know, obviously it's not going to work. So we need to wire in a cell logic service. Obviously my brain has died because I've just forgotten how to define a variable. So then what we're going to do then is basically for each cell we need to calculate its new state. So let's copy this logic again. Just return this for now, and we'll get rid of this stuff. So what we're going to do is we're going to map each row, and each row we're going to map each cell, and then we're going to create a new cell that we can return back, and we're going to use the cell logic service. We're going to give it the current cell. Helps if I call a function. I'm going to give it the current cell that we're trying to calculate, and then we need to work out the neighboring cells. So what is the easiest way of doing this? Let's create a function. So what do we need? We need a list of neighbor cells. So let's create a function called getNeighborCells. We want to pass in okay, so is there a map with index? Map indexed. Okay, here we go. That's how you do it? Yeah, okay. So what this is doing is it's creating, telling us what row we're on, and also giving us the row, and then here we can go map index, cell index. Alright, and then here we can say, hey, given a row index and a cell index, we want to get back a list of cells. Again, I've kind of deviated from TDD, so really not leading by a good example. So what we can do is remove this, and let's start. Let's start actually writing some tests. So probably jumped the gun. I think maybe I'm struggling because I went straight into the board rather than calculating neighbor cells. Probably a big mistake there. This is probably not a good name for a test either. Board with one hive cell should become all dead. So here we're just going to say get neighbor cells, can get neighbor cells, and we're going to just create board, and then we want to get row 0, 1, 2, 3, 4, so board.getNeighborCells, row 4, cell 0, 1, 2, 3, and this should be a list of, and then 9 dead cells all around it. Don't know how many this is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so we run this test. And we're expecting 9 dead cells. And we're not getting it. We're getting empty. So that makes sense. So what we're going to do is just go board, row index, cell index, dot state. Okay, so that is the cell. So what do we want to do? We want to go return list of. So we want to go row index -1, so the next previous row, and then cell index -1. Then we want to go cell index, and then cell index +1. So we get the previous row, the 3 cells. Then we want to get the current row, the cell to the right and left of it, and then we want to get the next row, and we want to get -1, +1. I don't know if that makes sense, but we're basically just getting all the neighboring cells. So if we run that, what are we getting wrong? I've miscounted. Okay, why am I miscounting? So we're off by 1. Does the README say? Is that right? Let me count. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, I can't count. There's 8. Alright, so let's go back to the test. So there should be get neighbor cells, 8 neighbor cells, 1, 2, 3, 4. So that's not very readable. So maybe we just go that filter it.state.dead. Their length should size 8, and the number of alive cells should have size 0. So hopefully this will work. So let me turn this into board with 1 alive cell. So here, if we get 4, 3, we should get 8 dead cells and 0 live cells. Can get neighbor cells that are alive. So here, if we get the next one along, right, we should get 7 dead cells and 1 alive cell. Because basically we're getting the cell next to the alive one. Cool, so that's working. So that's kind of, what about the edge condition, right? Like what happens if we can get neighbor on the edge of the board? Right, so if we go 0, well let's say row 4 but cell index 0, right on the edge, we would expect 8, 8, 0. Oh, yeah. well, I guess if we're going an infinite board, right? So like we just wrap around, should still have 8 neighbors, but we're going to get like a null index out of bounds exception. And if we go into here, you can see like our cell index -1 is not great. So how do we do this, right? So we want previous, my brain is dying and I've only got 7 minutes left. Val left cell is equal to if cell index -1 is less than 0, we want board 0.size -1. So this will go right around, and then else cell index -1. So basically, if we are on the edge of the board, we want to go to the far side of the board. Otherwise, just go 1 to the right. I think that makes sense. Yeah, helps if I actually use the variable. Right, so that's going to say, assuming, I mean, we need to assume here that every row has the same length cell, which we should probably have a test for that. So here we're going to do a test for row 4. So what about on the right hand side? So what do we say? Row 1, 0, 1, 2, 3, 4, 5, 6, 7. So if we go 7, it should blow up. What have I done? So this is getting it from the left. I'm going to get it from the right. So run the test. Index out of bounds. So let's do right cell. So on the right cell, if cell index +1 is equal to board 0.size, right? So if we're going to the right and we've reached the max, we want to just loop around to the edge. Otherwise, cell index +1. And then I keep forgetting to actually use the variable. I'm sure there's some smarter way of doing this, but right now I cannot think of it. So if we go back to the test, so now we want to go row 0, cell 4. So this is the top of the board. This should fail, which makes sense. So now I want to go val, let me try. And this could be top row. So top row goes if row index -1 is less than 0. So this is exactly the same as what we had before, but it's just board.size -1, else row index -1, run the test. So again, if we've gone up into the top, we want to loop around to the bottom, otherwise do that. and lucky last. So is there the same number? I think I've confused myself. 0, 1, 2, 3, 4, 5, 6, 7. So that's 7. Okay, there is the same number. So here, run this, get an index out of bounds exception. So that didn't fail. Maybe I miscounted. Let's go to 8. Got to find what the maximum is here. Cool. Actually, maybe I'll just change this. So it's 7 by 7 grid. Make things less confusing in the 2 minutes that we have left. Okay, so we just need to do the final thing. We want to go bottom row. So if row index plus 1 is equal to board.size, we want to loop around to the top, otherwise it should be row index plus 1, and we want to use and then we run the test. So here we've kind of got like an infinite grid, and it returns all the cells that we need. So if we go back down to here, let's run this test again. So it's still not calculating correctly because it has found an alive cell. So I wonder why. Oh, because we're returning this. So none of this was actually ever being returned. So if we just go return a new board, cell board. I'm watching the clock tick down, which is not conducive for writing good quality code. Cool, so you can see it's got one alive cell, and the next state so let's go print line. We've just run out of time. Next state and next board. So if we run this, you can see that we started off with one alive cell, and then the next state we end up with nothing because it died due to underpopulation. So yeah, that's kind of how it would go. Maybe I did very poorly because I didn't get super far. Maybe I did, who knows. But hopefully that made some sense. I think it's given me at least a little bit of how to tackle it. I think I'd do it completely different if I had my time again. I think jumping into kind of rendering it visually very early on was probably a bad idea. I should have done this get neighboring cell thing, and I think kind of doing an infinity board, yeah, maybe added some extra logic. I mean, I'm sure, like, I'm looking at this code here and it's like very ugly. I'm sure there's probably a much nicer way of kind of wrapping around the thing. So normally at now we would do a little retro session to talk about how we found the experience, any learnings. What I'm going to do is I'm just going to quickly try and get something going because I feel like I was so close. So let me get a stopwatch and see how much longer I needed to actually get something good. So what I'm going to do is we've kind of got this cell board. So I'm going to quickly just create a new, kind of giving up on, well, I'm not giving up on TDD. I'm just trying to actually write something now that is visual and kind of sees whether or not it all hung together, or if I'd made some terrible decisions along the way. So does it work? Basically is what I'm trying to know. So what we need to do is just quickly create a randomized row. How do you do math.random? So let's go if math.random is less than 0.5. So if the math.random is less than 0.5, I'm going to create a cell that is cell state alive. Otherwise, going to create a cell state that's dead. So I'm going to call this create cell, create random cell. And then what I want to do is I want to go for, shows you how long I do a for loops. God, how do you do a for loop in Kotlin? That's embarrassing. Amazingly, my brain is quite drained, I think, from this experience. So I think that's something to be mindful, is like, you know, on the day, people are going to be quite exhausted. So let's say we want to create, you know, a 20 long row, and then basically this is going to be a list. So can I do it? Does this even make sense anymore? How do I do like a stream? Let's just create. My brain is obviously given up. So I'm going to create rows equals mutable list of cells, and then for each one I want to create a new row, and this is going to be list of cell, and then in here I'm going to do another loop, and I'm going to go row.add, create random cell, helps if I make this a return statement, and then I'm going to go rows.add row. So it's going to create a list of rows. That can be a val, and then I want to create a new board, cell board of rows, and then I'm going to print wow, maybe doing this on a Friday afternoon wasn't the best for me. So if we run this, we've created a randomized cell board. That's way too many. Let me go 10. So, I mean, obviously, no, that's the wrong way. That should be 60, and this should be 10. So now we're getting something randomized. I think there's too many alive cells, so I'm going to make it rarer to get an alive cell by changing that to be less. Cool, so that kind of is a bit more what I want. So I think what we want to do then is just go while true. And then var board equals cell board. So we're just going to print the board, and then we're going to make the board calculate the next state, and then we're going to do a thread.sleep for 1 second. Something like that. So we're just going to keep looping through. Let's see if this makes any sense. So we're kind of seeing cells live and die. They're all kind of stuck. I think maybe one of our calculations were wrong, because I would expect some more movement. Like this pattern here, it's kind of not moving at all. But, you know, it's kind of working. Let me try running it again with a different seed. It would be nice to have like a top and bottom row being rendered. So yeah, I'm trying to think. Yeah, that kind of worked actually. Like I saw a cell come in. So I think we were pretty close. I think just with a little bit more time, you know, it would have been good. So I think for here, what we want to do is go, we want to print like board. How did we do that loop? I've already forgotten. Print. So basically, I just want to go for each thing in the board length size. Oh, +2, right? Because we need to do the edges, and we want to. So this is just adding a header row and a header bottom. Ooh, that did not go well. Why is that so short? Do I need to do board 0.size? I think I got my rows and columns. Yep, that looks good, but it needs a line break. Oh, I don't know what I'm doing. Oh, I'm an idiot. I only want to create the line break at the end. So this is where pairing, someone would have pointed out that was a typo there. Alright, it's kind of working. I forgot this. So yeah, I would create, if I could have my time again, I would do a lot more validation around like, is the number of rows provided, you know, are every row the same size? You must have at least one row, you know, and 3 cells or something, like minimum kind of validation stuff. It's a bit gung-ho, but I just wanted to kind of get something going. I think I also would have done different states, so like a cell that is dying from overpopulation versus a cell that is maybe a zombie cell or something, and actually have different symbols for those. Because at the moment, yeah, it's kind of a bit hard to kind of see what's going on here. But that took me 10 minutes over time, so it took me 55 minutes, but I feel like I got something going. Hopefully on the day I will be fresher and will be better suited, but it was a fun exercise. Definitely think that the minute I kind of deviated from doing TDD, I kind of went off the rails. I think I should have really started with getting this neighbor cell thing much earlier. Yeah, so it was a lot of fun. Hope this was interesting or valuable to anybody. Thanks for watching.